Hello, I'm Mr. McBride. This is TJ3M, Introduction to TinkerCAD. So yesterday we talked about schematics and the importance of these and how to go from circuits to schematics and from schematics to circuits. We will need a few more tools before we can truly get building circuits from our schematics. And we're going to do a little departure today. We're going to talk a bit about multimeters and the importance of these to circuits. That's a topic for a different video. And we're also going to talk about a circuit simulator, software that we can use to build virtual circuits and investigate their behavior. We're going to talk about the value of these and have a look at TinkerCAD for that purpose. So simulators are a fantastic tool for us to learn about computer engineering. They allow us to visualize the results when we build and interact with circuits, and they incorporate the theoretical behavior of given components to illustrate how these things work. Now, these have a whole bunch of benefits. One of the biggest is we don't have to buy hardware in order to build circuits. Another is that it's very quick to make changes. We'll find when we're building circuits in the lab that it sometimes takes a great deal of time to make a change. We might have to walk over to a cabinet to get a different component. But it may not be that simple. Sometimes we have to order a given component and wait days or weeks to get that component before we can make our change in our circuit. With a simulator, we can make the change in literally seconds. Another benefit is that mistakes in real circuits can sometimes burn out expensive components. Sometimes we're going to find ourselves having to replace components that when we made a very simple mistake in terms of wiring something backwards or forgetting a resistor. When we work with a simulator, it should indicate that mistake, and we're burning out virtual components, which are free to replace and don't take any time to go and obtain a new component. And closely associated with that is safety. We don't have to worry about components burning out, potentially doing things like causing a fire. These things are extremely rare in the computer engineering laboratory, but when we work with a simulator, we don't have to worry about this at all. Okay, so how do we get started? With TinkerCAD, your instructor should have created a classroom already and sent you your login information. So when you go to tinkercad.com, you can take and input your classroom code and then input your login name. And the first time you log in, it should ask you to set up a password. And after that point, you should be able to log in with that password each subsequent time. Okay, so now once you've logged in, there are a bunch of different options for you to navigate. And what you want to do is you want to move down to circuits. Choose circuits so that you can go ahead and use the circuit simulator today. Once you've done this, you can choose create new circuit, and this will create a project view for you to start work. Once you've done this, you can select your components from the right hand side and drag these components into your project window in order to construct your circuit. Now, once you put those components into the window, into the project window, and place them on that project window, you're not done. Normally, of course, you'd choose a component from a cabinet or from a parts bin, and that'd be that. in TinkerCAD, there's usually some configuration options associated with a given component. For example, you place a resistor, it'll immediately pop up a dialog that says what resistance do you want for this resistor, and allow you to label it if you feel you need to. So you need to be careful to make sure that your resistor is the correct resistance for the circuit you want to build today. Now, your components aren't inherently wired together, of course, when you place them in the project window. It's a little like throwing them on a table. They're not wired together once you put them in the project window. Our projects initially will mimic a soldered project. So we will simply use wires to connect things together. The difference between that and a breadboarded project will become obvious in subsequent videos. So what we'll do is we'll connect wires between our components in the appropriate order. To do this, click on the terminal of a component, drag to the next component, and then the pop-up window will allow you to color code your wire, and you should color code it the way you would in the laboratory so that it's clear what things are doing. So to start out, you can go ahead and build the circuit on the right, connecting up a very simple circuit, a 9-volt battery with a resistor. I believe this is a 1,000 ohm resistor. Connect that up to your LED and back to ground. So you can go ahead and build that circuit to practice. Now, once you've built that circuit, you'd expect the LED to light up immediately. In fact, TinkerCAD isn't set up that way. When you want to see the circuit work, you need to press Start Simulation. So there's a button on the right-hand side. So when you start the simulation, it's the equivalent of connecting power to your circuit, assuming that you have a power source as part of it. Your simulation will begin. Now, if you have things like LEDs, you can observe them working directly. Your LED will light up if you've wired it correctly, and you should see that with the circuit you built in the previous slide. Other circuit behavior has to be observed using a multimeter, and so you're going to be using a multimeter a lot in our activities going forward. So the multimeter is simply one of the components on the right-hand side. You can drag that component in, and using the multimeter in the correct fashion, according to the other video that we assigned for today, you will be able to see what happens when you make changes to your circuit in terms of potential, resistance, and current. And this very much reflects the real world. Lots of circuits are not visual in terms of what occurs when you make changes to them. And you need a multimeter to measure the effect of those changes. And also, like in the real world, if you don't wire your multimeter correctly, your multimeter will not function, and it won't give you the indication you expect. So you have to pay attention to the procedures for using a multimeter. Okay, to sum up then, TinkerCAD's a great tool for us to investigate and demonstrate circuit behavior. We can build simple or we can build complicated circuits using it and observe behavior that is theoretically sound. It's close to real-life behavior. And we can include one or more multimeters in our circuits to give us to allow us to measure the result before we build a circuit. For your homework, please complete the multimeter worksheet activity. Go ahead and work your way through that and create your report as appropriate. Okay, so a quick introduction to TinkerCAD demo. Once you've logged in, once you've signed in, you'll see on the left-hand side the options that you have. I've moved down to Circuits, and when I click Create New Circuit, this enables the Simple Project view. It creates a fun name for me in my project and gives me some simple tools down below. Now, there are lots of components I can drag in. We'll be using a lot of those later, but for our simple circuits today, we can just use LEDs, We can see we can drop it into our project window, name it, change its color, etc. And our LED, it's logical to connect it to a resistor. A 1000 ohm resistor will be fine. Notice that we tend to use 470s in our classroom, but remember, it's showing kilo ohms here. You got to pay attention to the units. So I've got a 470 ohm resistor connected here. Notice it changes the colors for us. We don't spend a lot of time talking about the color bands on those resistors, but it certainly does that calculation for us. Now, if we remember our components of a circuit, we have now a resistor. We need a power supply, so we can drag in our trusty 9-volt battery, just like in class. Of course, we can choose other kinds of batteries if we need them, change the potentials by putting them in series, that kind of thing. Now we have a power supply and we have a load. What are we missing? We're of course missing the conductors to connect these things up. Now, in order to wire these together, we don't have to get out a soldering iron in TinkerCAD. We can simply drag them together from one terminal to another. And hey, while we're at it, we might as well make sure our wire colors are appropriate. Now we've got our ground, our positive. We can connect this up to the longer wire on the LED. Make that wire red. And now we've got a very simple circuit here. A 470 ohm resistor, a 9-volt battery, and LED. But wait, it didn't light up. What's going on there? Well, the answer is we have to start the simulation before TinkerCAD will use theory to try to decide what's going on with our circuit. So we press the Start Simulation button and our LED lights up. And there we have it, our first simple circuit. Thanks very much. Have a great night.